So, in my podcast today, I'm going to go over quarrying on ancient Egypt, how the stone was freed. Written by Logan Huntington Bixler, 2026. You can visit my website at www.loganbixler.com or read my book on Amazon, The Resonant Pyramid. The disclaimer is in the channel description. When people imagine ancient Egyptian quarrying, they imagine force. They imagine men striking stone with copper chisels, pounding granite with dolerite balls, and somehow, through effort alone, freeing monolithic blocks from solid bedrock. But the stone itself rejects that story. Granite does not fracture cleanly under impact at scale. Impact creates chaos, crushed zones, uncontrolled cracks, shattered debris, and cumulative damage. None of that is what remains in Egyptian quarries. What remains instead is a controlled process. There's large, clean extractions, smooth concave undercuts, wave-like kerf patterns. They find rounded tools without impact scars, and the quarry floors, they look eroded, not battered. This means the question that has been asked is wrong. The question is not how much force was applied. The question is how resistance was reduced. Stone was conditioned before it was removed. Granite is not a static material. It is a composite of crystalline grains, microfractures, and natural planes that respond to the environment. When subjected to sustained vibration, low frequency, repeated, rhythmic, the internal structure of granite changes. Grain boundaries loosen. Microfractures extend along natural paths. Permeability increases. The effective resistance of the stone drops. Nothing moves, nothing lifts. Nothing breaks free yet. The stone simply becomes easier to work. Resonance here is not mystical. It is mechanical conditioning. The purpose is not to shatter the stone, but to make it receptive to abrasion, to slurry penetration, to controlled removal. The quarry was the tool, not a hole. Egyptian quarries were not random pits dug into bedrock. They were prepared landscapes. Broad, planar working surfaces allowed uniform action across large areas. Gentle downhill gradients guided slurry and debris away from active zones. Shallow corridors marked intended undercut paths long before separation occurred. Localized basins formed beside large monoliths, not everywhere. This only makes sense if quarrying was treated like a field scale process, not a chisel striking point, but in an environment doing all of this over time. The quarry itself participated in the extraction. The abrasion did the work. It wasn't from impact. Stone was removed by abrasion, not by people slamming rocks into each other. At the interface between tool and the stone existed a thin, active layer, a hydrogel-based slurry. Water carried fine abrasive particles. Clays and organic binders thickened the mixture so grit stayed suspended. The slurry flowed under motion, but stayed stable at rest. This layer cooled the stone. It prevented binding. It carried debris away. It allowed constant uniform shear. The slurry did not cut the stone. It enabled cutting. Without it, tools could chatter, seize, or shatter surfaces. With it, erosion becomes predictable. Dolerite was not a hammer. Thousands of rounded dolerite stones appear in Egyptian quarries. If these were pounders, they should show impact scars, crushed edges, spalling, and fractures. but they don't. Instead, they are smooth, rounded, some of them even look polished. Their geometry tells the truth. Dolerite function as a resonant mass. Placed in a slurry and subjected to vibration, the mass began to oscillate and orbit in a rotational type of oscillation, drifting microscopically across the stone surface. Pressure concentrated through the abrasive grit material was removed without shock. No pounding was required. No edges were needed. The stone ended because the system stayed within control. Removal happened in cycles. Quarrying did not proceed in straight lines. It proceeded in cycles. Slurry moved in laminar flow. Abrasive shear retreated to the surface incrementally. Then the process paused. Then it repeated. Each cycle left a subtle trace, a scallop, a wave, a band. These wave curve patterns are not tool marks in the conventional sense. They are time signatures. The quarry recorded how long the process ran, not how hard it was struck. So if you think about this in a mechanical or a project plan layout, they basically started where the pits were. They would put the slurry and they would mark the pit with the hydrogel. They would create the vibration. They would go ahead and get their pit with a groove in it. Then they would add the oscillation or vibration frequency input. And that in itself would create the micro vibrations. Now, we think, hey, let's set some stones on top of rock and then we can just go get something that vibrates them and we're going to do the same thing. What you have to understand is they had a whole process in place to do this. So one person they had different jobs just like any manufacturing company today. So when somebody got to work, they knew, hey, today I need to do this. So when they left the day before, they already knew what they had to do the next day. They came out and they started in the next step. So they put the hydrogel on top. They got enough there to give a groove. Once they were either able to chip it away, they could have pounded at the initial stone structure just to give it enough to hold the hydrogel into the shape they were wanting to get for the depth. And then they would have went, and the reason why they always picked a slope area for the huge monoliths, like the obelisk and different large granite beams and different stuff like that they used in the pyramids, is because they wanted to